Welcome to the fourth and the final part of the energy series. In this video, we are going to learn about the interchangeability of energy, the conservation of energy, and also about the relationship between energy and work. So, without any further delay, let's soar the sky. Till now, we have learned about different forms of energy and how they work. But what do you think? Do they get created by their own? What happens to the different forms of energy present in this universe after we have used them for a long time? This is how the topic interchangeability of energy comes into place. Actually, there is a different story altogether. Energy can neither be created nor be destroyed. You cannot create any new form of energy, nor you can destroy any existing form of energy in this universe. It can only change from one form to another. This is known as law of conservation of energy, and it's extremely important, so you may pause the video and note down this definition. The law of conservation of energy states that energy can neither be created nor be destroyed, and it can only change from one form to another. I will give you a very good example and explain it to you in details so that you can understand this. You may have experienced the thrill of riding a roller coaster. You know, when it goes high and low whenever it wants, the carts goes high and low. The motion of the roller coaster is in accordance with the law of conservation of energy. That means the motion of the roller coaster follows the law of conservation of energy. That is, the energy constantly changes from one form to another. Initially, you can see in the diagram when the roller coaster car or train is elevated, is taken up to a large height, point A, it has the maximum potential energy as the height is maximum, and we have read in the previous videos that more the height, more is the potential energy. Now when the roller coaster's cart is starting to descend slowly from the top, that is point B, it loses its potential energy and gains kinetic energy as it is in motion now, as it is gaining motion now. At this particular stage, when transformation from its potential energy to kinetic energy occurs, the roller coaster also gains speed, because more kinetic energy, more is your velocity or speed. At the lowest point, that is C, the roller coaster cart has maximum kinetic energy. When the roller coaster car climbs up again, then it starts losing potential energy, kinetic energy, and starts gaining potential energy. Hence, it slows down. So, more the potential energy, less will be its motion, so it's slowing down. This interchangeability of energy takes place till the end of the ride, keeping the total mechanical energy unchanged. This is how the total amount of energy present inside the roller coaster remains unchanged. It just changes its forms from potential to kinetic and vice versa. Let me give you another example so that you can understand it more clearly. Another very good example of conservation of energy or law of conservation of energy is also involved in the production of hydroelectric power. The source of hydroelectricity is nothing but flowing water. The kinetic energy of flowing water is used to generate electricity. The water from a flowing stream or river is collected in a reservoir called dam. The water stored in the dam is at a particular height, and it possesses a very large amount of potential energy as it is elevated from the ground. When this water is released, the stored water flows, which converts the stored potential energy into kinetic energy because it changes its state from rest to motion, which in turn helps to rotate the turbines, as you can see, that are connected to a generator. This generator then converts this mechanical energy produced due to the rotation of the turbines into electrical energy. The electric energy generated is then transmitted through long distance power lines. So in this example, we can see that the change of energy occurs firstly from potential to kinetic, then that mechanical energy is converted to electrical energy. Let's give you some more easy to understand examples. An electric bulb converts electrical energy to light energy and heat energy. An electric fan converts electrical energy to mechanical energy, specifically kinetic energy. Plants convert the solar energy that they trap by the process of photosynthesis into chemical energy, which is required for their growth. These are certain examples which you can find in day-to-day lives where the interchange of energy is concerned. Though we know that the total amount of energy present in the universe cannot be destroyed nor it can be created, there are various sources of energy, both renewable and non-renewable. We should be very careful not to finish all our non-renewable sources of energy so that our future generation does not feel the scarcity of energy. So, what we can do to conserve? We can shift our energy requirement from the non-renewable sources to the renewable sources slowly and gradually and completely, so that, say for example, the renewable source of energy are those energy which get renewed by the nature itself. So no matter how much we use them, they won't get finished. Say for example, the solar energy, the abundance of the sun's rays, the solar energy is so much that no matter how long we use it, how much we use it, there will be loads of it present for our future generations. So this is how we can. There are also other ways to conserve energy. Say for example, we should switch off the lights and fans to conserve the electrical energy that is available to our country, to our city, to our state. There are multiple other ways as well. So you should very well keep in mind, you should not use energy that is more than what you require. You should not waste energy at all, or else our future generation will be in trouble. There will not be any amount of energy left for them. The next topic is the relationship between work and energy. In the starting of this video, we have already discussed about the definition of energy, which is energy is the capacity of doing work. What does this mean? This means that the energy stored inside the body gets converted into the work that we do. And that also means that the work done by a body or work done on a body gets converted into its internal energy. So we can say that work and energy are interchangeable in nature. This is also known as the work energy principle. Now, what is the definition of the work energy principle? It states that work done on a body or by a body is equal to its change in kinetic energy, because later on you will know work formula is force into displacement towards that force. That means there is some kind of a motion involved in work done. So, which particular energy is the most closely related to work? It is kinetic energy. The change in kinetic energy tells us the work done on a body or the work done by a body, and its formula is W equals to KE2 minus KE1, where W is the work done, KE2 is your final kinetic energy, and KE1 is your initial kinetic energy of the body. The difference between the final kinetic energy acquired by the body and its initial kinetic energy gives us the work done by the body or the work done on a body. So here we come to the end of the energy series. Thank you for watching. Please subscribe to our channel because the next series that is coming up is the heat energy. Thank you.